Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Josh Kramlick.
Hello, everyone. Thanks for joining us for today's installment of Tech to Tech by KYZEN Corporation. Today, we'd like to talk about solvent versus aqueous cleaning, and we'd like to frame this as a decision framework for process selection. As you may have already concluded from previous Tech to Techs, this is not quite a black and white proposition. First, I'd like to talk about the wide world of parts cleaning technologies. As you can see from this graphic here, there are really numerous technology options available. Vapor degreasing, aqueous processes, plasma cleaning, thermal, laser ablation, CO2 cleaning, media blasting. Those are all potentially applications that can be used. As KYZEN Corporation really focuses on vapor, vacuum degreasing, and co-solvent cleaning, as well as aqueous immersion and spray, this is what we're going to focus our discussion on today. So the first consideration in this framework is compatibility. We talk about substrate compatibility on a very frequent basis. We're looking at things like corrosion, discoloration as potential concerns, reactivity, softening, and decomposition. For example, with corrosion, the image on the left here shows some flash rusting on a ferrous alloy, which is a common concern. We could also have issues with reactivity. For example, if we're machining magnesium or titanium components and cleaning them in a water-based solution, there's a potential risk there. Softening and decomposition. These are more common concerns with thermoset or thermoplastic materials, where the cleaning chemistry can actually degrade some of those properties like durometer or something similar. We also have to think about soils compatibility. We frequently discuss on these Tech to Techs about selection of polar versus non-polar solvents based on the nature of the contamination. If we're cleaning ionic contamination, we're going to need a polar chemistry to remove that. If we're cleaning oils and greases, often a non-polar solvent will be sufficient. We also have to think about reactivity with the soils and concerns about potentially precipitate. So sometimes the solution can cause solids to drop out and accumulate on the bottom of a process tank. And then from time to time, there are some very mysterious interactions that happen that we don't need to go into today. When we talk about compatibility, here's a bit of a cheat sheet that we use. If we're looking at removing carbonaceous soils, burnt on oils and greases, that is always going to be an aqueous process for us. Other partners may employ something like a mechanical, media blasting, or maybe laser ablation to remove those, but for us, it's going to be aqueous. Same is true for oxidation and corrosion. If we've got, for example, oxide buildup on aluminum components here, that's going to be an acid-based aqueous solution for us. However, if we've got parts that are really just covered in oils or grease with no other substantial contamination, we do have options for both solvent and aqueous processes there. Your chemical supplier should be able to provide some existing compatibility data to help you make these decisions. For example, here we have one of our alkaline chemistries that's targeted for ferrous parts cleaning and protection, and you can see that we have a lot of data on metals as well as plastics and rubbers as well. Second consideration in this framework is compliance. This is really a regulatory concern. If we begin looking at water disposal regulations, these are going to vary drastically from one municipality to another. In some cases, you may only need to prove that your water bath is pH neutral to send it to drain. In other locations, you may need to provide biological oxygen demand data, chemical oxygen demand data, chelation, heavy metals analysis, etc. If you're in one of these more restrictive municipalities, it may be necessary that you consider hazardous waste collection or potentially installing evaporation systems. Another concern could be VOC restrictions. Volatile organic compounds, for our friends in California, are very familiar with this. The California Air Resources Board and the Southern Coast Air Quality Management District have very strict regulations on the amount of VOCs that can be released into the atmosphere. There are also other environmental concerns. We talk often about PFAS, per and polyfluoroalkyl substances. The regulations put forth by the EPA, which are still in the process of being implemented. But we also have state-to-state regulations like the Minnesota Pollution Control Agency and the Maine Department of Environmental Protection that may have actually even more strict requirements to follow. The third consideration, of course, is cost. When we talk about capital, we're not just talking about the cleaning equipment itself and the investment in that, but also any ancillary facilities investment that needs to be considered. DI water systems, for example, evaporators, lifting pumps and holding tanks, exhaust, and potentially even something like fire suppression if your cleaning process employs IPA. The next consideration here is consumables. We have to calculate and account for the first fill of a system, especially true with solvents where we use 100% of the concentration of that chemistry. The ongoing consumption, which can be difficult to estimate in the beginning of a process, and one that's often not considered carefully is maintenance. We have to think about the changing of filters, the addition of process additives, labor, and in some cases, we even need to account for auditing and certification if, for example, we're in one of those highly restrictive VOC areas. Utilities is the next major concern. Energy consumption on a cleaning system can actually be quite high. But if you compare a solvent system to an aqueous system, you might find quite a difference in the kVA rating on those machines. And that should come into the calculation. Water usage, of course, your raw water usage for your facility and the ability that you have to reutilize that water for some other applications should be considered. And of course, waste disposal, as we just discussed. All of that should feed into a total cost of ownership model. And if we're comparing multiple processes, that should really be based on an ROI comparison. There are, of course, other embedded considerations in all of this. Number one is operator safety and exposure. Second would be soil loading and expected bath life. Again, this can be difficult to estimate at the beginning of a project, but it can have a big impact on the consumption. Throughput, of course, this should really drive the specification of your cleaning system, basket size, tank size, etc. And often system footprint is actually one of the main driving factors as a customer considers whether to go with an aqueous or a solvent process. I'd like to walk through a few hypothetical examples to explain the framework of the decisions here. For example, if we're cleaning bulk stamped copper components or machined copper components as we have here, we have a few potential process options. One would be vapor degreasing. Second would be vacuum degreasing, and third would be aqueous cleaning. All of those could potentially be viable for this application. Let's assume for the sake of this example that we're in one of those highly restricted VOC areas and we just want to eliminate vapor degreasing out of the gate. So if we compare vacuum degreasing and aqueous cleaning, theoretical estimates on the investment, maybe a vacuum degreasing system might cost us $300,000. An aqueous system might be $150K. Annual operating costs should be quite a bit lower on the vacuum degreasing system. The solvent consumption is going to be low. The energy costs are likely lower. So if we look at a break even between those two technologies, we could say at 2.7 years, the higher initial investment actually ends up paying off in the long run. But for other considerations, such as oxidation of copper parts, we think that eliminating aqueous cleaning also makes sense here. So we select vacuum degreasing. We have a second example to share, PCBA defluxing, which is a world that KYZEN plays in quite frequently. We have two potential process options. We could look at vapor degreasing or aqueous cleaning. We're already going to rule out vacuum degreasing because the vacuum degreasing solvents are not effective at removing flux residues. So we walk through the same process here. If we estimate an investment for vapor degreasing at $150,000 and an investment for aqueous spray and air at $350,000. We look at annual operating costs. We may actually find also that the aqueous ultrasonic process, or the aqueous spray and air process, in this case, would have a higher annual operating cost than vapor degreasing. So that would say there's no break even. The aqueous process is always going to have a higher cost of ownership. But if we look at potential concerns about component compatibility on the boards with the vapor degreasing solvent, that might push us straight to the aqueous cleaning process. Just an example of the considerations here. So in summary, multiple viable process options may always exist. So it's important to carefully evaluate compatibility, compliance, and cost concerns. We always encourage our customers to consult with your equipment and chemistry partners and discuss these in detail. And most importantly, to let the data speak for itself. So we'll close with a few frequently asked questions on this topic. Does a solvent process or an aqueous process have a lower total cost of ownership? Unfortunately, it's not a black and white answer here. There are so many considerations when you look at your consumables cost, your utilities cost, floor space, and capital investment. But those have to be part of a very carefully thought out total cost of ownership model. Second question, what is the one best option for my parts cleaning application? Unfortunately, we often have to tell customers the same thing here. It's not a black and white answer, but your KYZEN representative is always happy to work through the models with you to understand all the considerations of your process and your facilities and see if we can help you work out the best solution. Finally, how can I determine whether my spent cleaning bath can be sent to drain? As we mentioned earlier, this is a phone call to your local water municipal authority because these vary so much from state to state and town to town that you really have to understand the specific regulations where your facility is based. So with that, I'd like to close up and thank you for your time today. And thanks for joining Tech to Tech.
Thanks, Josh. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.